Hey guys, today we're going to solve LeetCode 236, lowest common ancestor of a binary tree. So we need to find, given a binary tree, the lowest common ancestor of two given nodes as input. So in this example here, the two nodes are 5 and 1, and the lowest common ancestor of those two nodes is 3. Now notice here down in the nodes it says a very important thing. All of the nodes values will be unique, and P and Q are different and both exist in the binary tree. So this is really key to solve the problem, because the values are unique in the tree. Imagine if that wasn't the case. Like, let's say that there was another one here, okay? So if that was the case, if there was another one here, then this tree wouldn't be the correct solution. The correct solution will be this 5, because that would have both 5 and 1 as its descendants, and so according to this definition at least, and so 5 would be deeper than 3, and so that would be the solution. However, that can't be the case because the keys are unique. The values in the tree are unique. So essentially what this allows to do is return the current node that we are visiting as soon as we find out that this tree has as descendants both P and Q. So that's all we have to do. We need to traverse the tree, and as soon as we find one node that has both P and Q as its descendants, return straight away. So here's the recursion that we're going to use. First of all, the base cases, if we ended up on a null root, just return false. This is very common. Then if this current root is either P or Q, then we need to return this current node. Then this is the other base case. Then here's where the recursion kicks in. We're going to store in this variable the left child of our current node that contains either P or Q. And to do that, we're just going to call the same function on root.left. And now we also need the right child that contains P or Q. Just the same thing, but calling on root.right. Now, you see why this line is important. We need to return the current node if it is equal to P or Q, because we need it to store in these variables for these recursive calls. And now comes the recursion formula. So remember, as I said, we need to return straight away as soon as we find one node in the tree that has both the P and Q as descendants of itself. So as soon as we find that both of these values are truthy, so they are both instances of a tree node and they are not just a false value, then return the current node. And if this is not true, it means that we can return the one that is truthy. So one of those two is going to have to be false, because if both were truthy, then we would have ended up in this case, so we would have already returned. So either this one is true or this one is true. And for example, if this one is true, then it means that we are, for example, bubbling up this result. So we want this result to end up to the first call of lowest common ancestor, so that it will be used as an output for the beginning call. So that's what we are doing right here. Remember how the JavaScript operator works, or operator works. So you can see that it gets accepted, and it is an optimal solution because we're only visiting every tree node once. So that's impossible to do any better than visiting every node once. And memory-wise, we're just traversing the tree with a depth-first traversal, which is O of n. So that's it for now, and bye.